Okay, so this one's about inverse functions, and hopefully it won't be too long. We'll see. Hopefully 8 minutes. We'll see. We'll at the end if I make it. First, let's look at verifying. Let's understand what inverse functions are first, and I guess a way to do it is to talk about how do we verify if two functions are inverses. So one method is by using a map. Okay, we've seen some maps before. I'm going to draw one that's not actually mathematical. So here's a set, and here's a set, and I'm going to have some function that maps these values to those values, and here are my values. Hartford, West Haven, New Haven, and my hometown, well, not hometown, my hometown's in Pennsylvania, but where I currently live, Danbury, Connecticut. And so this is municipalities in Connecticut, and this is the estimated population in 2015. That's the website that came up, so I don't know why it's not more recent than that, but not going to fight about it too much. So the population of Hartford was 124,006, so I'm going to round it to 124K. I'm going to round all these values. West Haven was 54,927. And New Haven was 130,322. And Danbury was 84,657, which rounds to 85K. So this function, whatever it is, and when you think mathematical functions, you're not putting the word Hartford in there. But think of the function as a computer in this particular case. If I type in Hartford, boom, out comes a bunch of information. One of the pieces of information is the population, and it's 124K. If I type in West Haven, boom, out comes 54K. If I type in New Haven, boom, 130K, and so on. And in my set only has these cities, because if we had more, we might have overlap. We might not have a function that's one-to-one. And that's kind of a requirement, but we'll talk about that at the end. So this set maps to this set using this function. Now, to be an inverse, or the example of the inverse would be, how do I look at these two sets and create and view the inverse function? I'm not going to be able to write a function because it's not mathematical, but the inverse function would be that function that takes the population of 2015, the estimated population, 124K, 85K, what was the other one? 55K and 130K. I'm just trying to remember them. And it maps them to their appropriate cities. So West Haven, New Haven, Danbury, and what was the other one? Hartford. Okay. And so what happens is the inverse function should map this to its correct city, and that was Hartford, and 85K to Danbury, 55K to West Haven, and 130K to New Haven. So it would do that mapping because it's the inverse. Now, if we see that what's happening there, what would happen is, like, if I just punched in West Haven into one function, this first one, right, out comes 54K. So West Haven into the original function gives me, what did I say, 55K. Now, if I take the inverse function and put in 55K, out comes West Haven, right? And then if I put that into the original function again, out comes 55K. So another way, and so this would be just a big giant loop. We just keep going and keep going and keep going and keep going because it keeps generating the other input. Okay? So if another way to look at that is that my function, if I use my original function and use it as its input, the inverse function's output of some x value, I'll get the original x value. It would be that loop. I put 2 in, get 7. Put 7 into the other one, get 2. Put 2 in back to the first, I'll get 7. 7 back into the other one, I'll get 2. 2, 7, 2, 7, 2, 7, 2, 7. It's the same thing. And so for functions to be inverses of each other, this would be the verifying part, right? That's this part. For functions to be inverses of each other, this must be true. If I start with my inverse function, take its output from a particular value and put it into my original function, I should get the original value. And it needs to work in the other direction as well. So if I start out with by putting some value into my original function, take the output of that and put it into my inverse function, I should get the original value. Okay, so to verify, both of these have to be true. Okay, we don't have to use maps though some people would prefer maps. We can use ordered pairs. Okay, so the example I had was longer. I'm going to make it a little bit shorter. -3, negative 27, comma, -2, comma, -8. Another ordered pair would be -1, -1, and let's say 0, 0. They had a bunch of positive numbers, but I'm trying to make this shorter. The inverse of that, the inverse would be -27, -3, -8, -2, -1, -1. Of course, that one doesn't matter. And 0, 0. That one doesn't matter because they're the same values. And this is a different way to look at this or think of this is my input. So if I put -3 in, out comes -27. But with the inverse function, if I put -27 in, out comes -3. Then again, that loop, if I take this -3, put it into the original function, boom, out comes -27. And you could do that with all of these pairs of x's and y's. Remember, this isn't input in this case, and this isn't output because the input and outputs are the x's and y's. So that's how we'd look at it with an ordered pair. Another way to look at it is algebraically. I'm sorry. We want to go to graphically. Yeah. Another way to look at it is via a graph. And so if I have some y-axis, of course, and some x-axis, functions look like this. I'm going to draw a function not related to what we're talking about. And I mean, it's related to what we're talking about. It's not one of the functions, though, I guess is what I'm getting at. And this might be familiar to you. I certainly hope it is. That's not correct. That's better. Okay, so this function is the function y equals x. Okay, inverse functions are reflections of each other in the coordinate plane. So let's say that this is my function. Okay, that function is 1 to 1. If you're not recalling what 1 to 1 is, it's in the video previous to this one. And so inverse functions are reflections of each other about this axis. So in other words, take this and reflect it to the other side. So we would get this kind of thing, and then this would come down this way. You go like that. And so blue becomes the inverse of the orange function, or the orange function is the inverse of the blue function. Yes, it's not greatly drawn, but hopefully you get the idea. If I had a different function, for instance, I'm just going to sketch this one so it's a little faster. Okay. If I had this function, let's say a line that looked like this, its inverse would look something like something like that, because remember, it's reflected about this axis. So this gets pushed over there and this gets flipped over there. So the reflections of each other about this axis, y equals x. Okay? And the last way that we would go about doing it is algebraically. And so algebraically is probably the one that you're most familiar with. If I have some function, let's say it's 2x plus 3, to determine, this is no longer verifying, this is determining or finding the inverse function. What you do is you change the f of x to y, so it's easier to work with, essentially. Then you're going to switch the x and the y so that this is x equals 2y plus 3. Then you're going to solve for y so we can get back to this function notation. So if I solve for y, I'm going to subtract 3 from both sides and then divide both sides by 2. And I get y equals x minus 3 divided by 2. Or if you prefer slope-intercept form, 1/2 x minus 3 halves. And then we would want to write that in function form. And that function, in fact, is the inverse of my original function. If you're not sure, we can check it. I'm not going to go through the whole check, but I'm going to write the idea out. Remember, to verify if two functions are inverses of each other, you have to check to see if this results in the original value and if this results in the original value. Okay? So both directions. That should be it. Hopefully I was under 8 minutes. It doesn't feel like I was. All right? Take care.